Hello, pre-cal babies. Okay, we have arrived at the end of Unit 5, and we are now going to be talking about arc length, sector area, and linear and angular velocity. So hopefully I can keep this down to a pretty short video, we'll see. So the first thing we're going to talk about is finding the arc length, and this is just the measure of a portion of a circle's circumference. Well, if I could spell circumference. How frightening. Okay, so let's look at a picture of a circle here. So I'm just going to draw a little circle. It's not my best circle. But let's take an arc out of that circle where this angle measure is theta, and the radius is r. We're all accustomed to that. And then let's look at this. Oh, I did not mean to do that. Let's make that a little smaller. Okay, so the arc length would be this right here, just that portion of the circumference, and we're going to call that S. That is going to represent the arc length, so I will just write that here so we'll remember it. And then of course theta represents what we call a central angle. So that central angle is a portion of the 360 degrees about the circle, and of course this little green area here, that arc, is going to be a portion of the circumference. So there's actually an equation here that we can use. The arc length is actually equal to the radius times that central angle. Okay? All right, so something that is important about these problems, this will help you. We are going to convert degree measures for theta. Okay, so for that central angle, we are going to convert those to radians. And you might be asking why, because we don't like radians, Miss Griggs. Well, here's why. Circumference, if you remember from geometry, circumference is in terms of pi, okay? Because the circumference formula is 2 pi r. So that is the reason we're going to use that. So let's just look at some examples here. Okay, I've got example 1 and example 2. So for example 1, I'm given the radius of 12 centimeters and angle theta is pi over 3. So if I want the arc length for that, and just to give you a visual, what does that look like? Let's say I've got 12 right here, pi over 3. So basically what I want to know is, I want to know this measure right here. It's a portion of the circumference. So all I need to do, this is S, represents the arc length. I'm going to take 12 times pi over 3, and that reduces to 4 pi centimeters. Or if you find it in the calculator, 12.6 centimeters. And to take it a step further, if you'll think about the circumference of this being 2 pi r, that would mean, since I've got a radius of 12 here, the 12 is going to multiply by this, so that gives me 24 pi. And if you'll think about it, if you look at the circle being cut up into pi over 3, remember we've talked about that before, there are 6 slices of the circle, and each one of those would represent pi over 3. So the top half of the circle cut into 3 equal pieces, the bottom half of the circle cut into 3 equal pieces. So the circumference around the whole circle is 24 pi. So it would make sense that a sixth of it, we divide this by 6, would give us 4 pi for this one little slice right here of our circumference. So that's just to help you kind of understand how this works. Okay, the second example, we have a radius of 20 inches and theta is given as 100 degrees. Well, remember, I told you right up here, it will make your life easier if you'll convert 100 degrees into radians. So that's what we're going to do first. So I'm going to take this 100 degrees and I'm going to multiply it by pi over 180. That's how we do those conversions. And after reducing, I get 5 pi over 9. And then I need to use my formula, which is 20 times 5 pi over 9. So an arc length for a circle with a radius of 20 inches, the arc length for that 100 degree mark is going to be 100 pi over 9 inches, or if you multiply that, if you get it in your calculator, 34.9 inches. All right, so that is how we find the arc length.